Welcome to ZoomInData. Today we're diving into the integration between Azure Data Factory and Azure Databricks, a powerful combination for orchestrating data ingestion, complex transformations using Spark, and building scalable ETL or ELT pipelines in a modern lakehouse architecture. We'll cover setup, best practices, security, cost optimization, and real-world patterns. Let's get started and see how this integration can elevate your data engineering workflows. Azure Databricks is a fully managed analytics platform built on Apache Spark, delivering a lakehouse architecture with Delta Lake for reliable data management. It supports collaborative notebooks in Python, Scala, SQL, and R, along with workflows for job orchestration and scheduling. Compute options include serverless, job clusters for automated runs, and all-purpose clusters for interactive work. It also includes advanced features like machine learning tools, Delta Live tables for streaming, and Unity Catalog for governance. Integrating ADF with Databricks combines the strengths of both. ADF excels at orchestrating data movement from over 100 sources with no-code, low-code pipelines, while Databricks handles heavy Spark-based transformations, ML, and lakehouse processing. Together, they enable true end-to-end workflows. Ingest with ADF, transform in Databricks, and load back auto analytics tools. You can trigger Databricks workflows natively from ADF, scale efficiently with job clusters, and benefit from unified monitoring and security across Azure services. There are several ways to integrate. The foundation is the Databricks linked service for connectivity. The notebook activity lets you run individual notebooks directly. However, the Databricks job activity, introduced as native support, is now the recommended best practice for triggering entire Databricks workflows or jobs from ADF. You can also use web activity with the Databricks Jobs API for custom calls, or trigger Delta Live tables pipelines. Additional options include Jar, Python, or Scala activities for specific code execution. Setup starts in ADF Studio under Manage and Linked Services. Click New and choose Azure Databricks. Enter your Databricks workspace URL and select Authentication. Managed identity is the secure best practice, avoiding PAT management. For clusters, choose an existing interactive one for quick testing or define a new job cluster for production. Add optional settings like init scripts, libraries, or instance pools. Finally, test the connection and save. This enables all subsequent activities. The Databricks job activity is the modern best practice for integration. In your ADF pipeline, drag the activity onto the canvas, select your Databricks linked service, and pick the target workflow or job from the drop-down. It lists accessible ones based on permissions. Pass parameters dynamically from ADF. Importantly, no cluster configuration is required here. It uses the job's own definition for execution. This supports advanced features like repair runs, reruns, and cluster reuse for better efficiency. For finer control, use notebook activity to execute a single notebook. Specify the path in .dbc, py, or Scala format. Jar activity runs compiled Java, Scala jars, while Python activity handles standalone, py scripts. Select cluster type. Prefer job clusters for isolation. Pass base parameters or dynamic values from ADF expressions. You can capture outputs or status for downstream logic in the pipeline. Cluster choice impacts cost and performance. Job clusters spin up on demand for each run and auto-terminate, making them highly cost-effective for ADF-triggered workloads. Interactive clusters stay running for development and debugging but cost more. Instance pools pre-warm nodes to reduce startup latency while keeping job cluster benefits. Serverless options eliminate management entirely with pay-per-use pricing. The best practice for ADF is job clusters combined with pools for fast, economical executions. Parameter parsing is flexible. Define parameters in your ADF pipeline and map them to Databricks job or notebook parameters using expressions like @pipeline, parameters, myparam. This enables dynamic notebook paths, configuration values, or runtime filters. Set base parameters directly in the activity. For sensitive data, reference Azure Key Vault secrets to keep them secure and avoid hardcoding. Security starts with managed identity authentication in the linked service. It's the best practice, eliminating pat rotation and exposure risks. Use Azure Key Vault to store any remaining secrets, tokens, or dynamic configs, referenced safely in activities. Apply RBAC roles like contributor on the Databricks workspace. Enable private endpoints for private network traffic, and leverage Unity Catalog for fine-grained data access and governance across the lakehouse. For secure networking, create a private endpoint to your Databricks workspace to keep control plane access private. Use VNet injection for compute clusters and managed private endpoints from ADF for outbound connections. Apply network security groups and firewalls to restrict traffic. This setup eliminates public internet exposure entirely. When combined with ADF's managed virtual network, you achieve end-to-end private connectivity. Monitoring combines both tools. Use ADF's Monitor Hub for pipeline and activity status overview. In Databricks, check the jobs UI for detailed Spark logs, execution metrics, and history. Enable diagnostic settings to send logs to Log Analytics for unified querying. Set up alerts in Azure Monitor for failures or long-running jobs. Integrate fully with Azure Monitor, and use the Spark UI in Databricks for deep query and performance optimization. Cost optimization is crucial with Databricks DBU-based pricing. Always use job clusters attached to instance pools for quick startup and termination, minimizing idle time. Enable auto-termination and auto-scaling on clusters. Prefer serverless compute for variable workloads to avoid management overhead. Avoid running too many parallel notebook activities from ADF to prevent cluster spin-up spikes. For streaming, Delta Live Tables offers efficient processing. Track DBU consumption in Azure Cost Management and set budgets, alerts. Common patterns include using ADF to ingest data from diverse sources and then trigger a Databricks workflow for processing. For lakehouse tables, run incremental loads with notebook activities performing merge or UPSERT operations. Trigger Delta Live Tables pipelines directly via the job activity for reliable streaming. In ML scenarios, ADF orchestrates data prep before handing off to Databricks ML flow for training. For hybrid, combine self-hosted IR in ADF with Databricks for on-premises connectivity. In real-world use, daily ETL often involves ADF ingesting from sources like databases or files, then triggering Databricks for transformations and loading to the lakehouse. For streaming change data capture, ADF detects changes and triggers Delta Live Tables pipelines. ML pipelines use ADF for data preparation before model training in Databricks. To fix cost spikes, Teams switch from interactive to job clusters with pools. Secure migrations replace PATs with managed identity for better governance. Here are conceptual interview questions. What is the Databricks job activity in ADF? And why is it now the preferred integration method? What's the key difference between notebook activity and job activity? How do you configure managed identity authentication for Databricks in ADF? Which cluster type is best for jobs triggered from ADF, and why? How can you pass parameters dynamically from ADF pipelines to Databricks jobs or notebooks? Scenario-based questions include: your Databricks costs are high when triggered from ADF pipelines. How would you optimize? How do you trigger a Delta Live Tables pipeline directly from ADF? A notebook activity fails intermittently. What troubleshooting steps? Walk through migrating an existing framework from notebook activities to the new job activity. Secure Databricks access from ADF without using PAT tokens. And how to handle dynamic notebook or job selection at runtime based on ADF parameters. That concludes our session on Azure Data Factory plus Azure Databricks integration, from setup and native activities to security, cost savings, and advanced patterns. Thank you very much for watching. If this gave you clear ideas on building efficient Spark-powered pipelines, please subscribe to ZoomInData for more Azure Data Factory, Databricks, and data engineering topics. Like the video if it helped, share your thoughts or questions in the comments, and pass it along to your network. Thanks again. See you in the next one.